Today, we will learn about a very important topic of organic chemistry. In organic chemistry, there are many name reactions. These name reactions form the basis of organic conversions. Such organic conversions occur in both board exams as well as competitive exams. So, let's consider some of the important name reactions one by one. You may please get your pen and paper and we can start discussing. I'm sharing the whiteboard. So, first begin with the very famous reaction, that is Aldol condensation. This reaction involves carbonyl compounds, mainly aldehyde, which have alpha hydrogen. So, let us first discuss about this reaction. Then we will consider the examples. So, aldehydes having alpha hydrogen undergo self-condensation on warming with dilute or mild base, could be either NaOH or could be KOH, to give beta hydroxy aldehyde. Called aldol. Hence the name aldol. So very often we get confused, or very often students get confused in the various reactions, name reactions. So the name itself suggests aldol means the starting product is an aldehyde and it will undergo self-condensation to give you aldehyde plus alcohol. Let us consider the reaction. The most important parameter in this is these aldehydes have alpha hydrogen. Let us consider the example of acetaldehyde, which is also known as ethanol. So, two such molecules will combine together in the presence of base to give you CH3, CHOH, CH2, CHO. This compound is known as acetaldol. Let us study the mechanism. Stepwise mechanism. So, first you have OH minus, that is base. It will abstract. The first step involves abstraction of proton from I write it like this. So this will get abstracted. And what I'm left with is CH2, C double bond O, H with a negative charge. So the first step is generation of resonance stabilized enolate ion. Why I'm saying a resonance stabilized? Because it can have two structures like this. So these two structures are possible for this enolate ion. Now this, in the second step, this enolate ion will go and attack another molecule of acetaldehyde. So this is my acetaldehyde and this is my enolate ion. So it will go and attack here. This bond will open. What I'm left with is CH3, CHO. Obviously, it already has two lone pairs and this bond is opening. So the oxygen gets a negative charge and the rest of the structure we write as it is. So this is the second step. Now to this, water is added. Water, I can write it as H2O, or for understanding better, I can write it as the same water as HOH. So what happens is this O negative will have a tendency to take that proton from water to give you CH3. CH3 and CH OH CH. The next step involves elimination of water. So first water is added and in the next step water will be removed. So there is a possibility of removal of water. So we will stop at this step itself. This is acetaldol. So you can have innumerable examples for aldol condensation. So some of the examples could be we instead of one single aldehyde, we can also have a mixture of aldehyde. Then in that case, the reaction is known as cross aldol condensation. So let us take one example of cross aldol reaction. So what I wanted to say in the above step before we proceed for cross aldol is if we have removal of water, then we can get CH3, CH double bond CH, this kind of alpha beta unsaturated compound. Next, we begin with cross aldol condensation. So, in cross aldol condensation, I can have ketone and acetaldehyde. So this is my acetaldehyde, and I can also have acetone. So in this case, when I am considering alkali, then what I am left with is CH3, CHOH, and CH2, C double bond O, CH3. This is known as 4-hydroxy pentane 2-one. Let us name it. So it will be like this. Naming will proceed this way. So it will be 4-hydroxy pentane 2-one. Cross aldol product. Very good example of this. It is important in aldol condensation that at least one of the compounds have alpha hydrogen. For example, we can also take an example of benzaldehyde and ketone. In this case, so I have this benzaldehyde and another one is ketone. So in this case, it is acetone which will be undergoing or which will be forming enolate ion because benzaldehyde has no alpha hydrogen. So in this case, the obtained product is C6H5 CH. What can be another memory technique is as follows. For example, if you want to predict, important, if you want to predict the final product of either aldol condensation or crossed aldol condensation. So this is how you can remember. Instead of writing acetone in this way, I can write it as memory tip. Hence, I'm putting it in green. And this I have is benzaldehyde. So these two molecules are there. What I can do is I can remember it like this. And finally, if you are speaking about the product, it will be CH double bond CH, C double bond O, CH3. You see, above you will have the same product, CH double bond CH double bond CH3. So let's practice. This is the name of this compound is benzylidene acetone. This is memory technique. So if you just remember to remove water molecule, you can easily write the product, final product of this particular reaction. So let us practice. So I give you another compound, C6H5, again benzaldehyde. Now instead of ketone, I have this compound. Again, note here, instead of apart from having the aromatic nucleus, it has this alpha hydrogen. Alpha hydrogen means adjacent to the carbon atom, there should be hydrogen. So this is 1 and this is the adjacent position is known as alpha. So again, alkali. I think I've written alkali here also. Yeah. So if I want to predict the final product for this, it will be what? First, your aromatic nucleus. Then you write CH. Then instead of C double bond O, this will be eliminated. Double bond will be like this only. And you will have CH, C double bond O, and another benzene nucleus. So this is known as benzylidene acetophenone. So I begin with benzaldehyde. and this is acetophenone, and I end up with benzylidene acetophenone. So that is all about the aldol condensation and crossed aldol condensation.